Hey, and we are live. I am going to give this a little bit of a talk at so that I can see how people are hearing. If people would get on Slack and let me know how I'm doing. I thought for a moment we were in trouble. There is a lecture kicking off. Yeah. Pasting the link probably makes it easier for people to get in. Okay. Can everybody hear me? How is life? Please let me know if you're in, if you're hearing me, if I'm not talking to myself, etc. I can't hear anything. Don't know if it's me. I see Joe Taylor showed up on the chat. Joe, if you're hearing me, please use the Slack. It's far easier to read the Slack while I'm doing this. Well, I just posted the YouTube link. Okay, and now I've delivered. Okay, great. Okay, and somebody else posted it as well. You hear clicks. There's no reason why you should be hearing clicks. Okay. Okay, Patrick can hear. All right, good. Jamie, I don't know what's going on that you're hearing clicks. Others are hearing clicks. Yes, there will be a 10-second. There's 10 seconds button. I had to compromise between the delay. Okay, good. All right. Joe, I understand about the reverb. There's nothing more I can do about the reverb. I think that's inherent in me being in Europe. On a really crummy line. And Charlie, I don't know what to say. Other people are hearing me. I'm going to just keep talking until a bit of the video problems calm down. Okay. All right. Okay, Joe, I'm sorry about the reverb, but I don't know how to fix that. I don't. Okay. Wow, and even oh, we can hear you. Your audio is a little disturbed. My mic gain might be too high. That's quite possible. Okay, I'm going to, I have just turned down my mic. Did that help? Testing, testing. We're now in a not coming quite so close to the clipping region. Okay, I'm going to assume this is as good as it gets, and I'm going to go on with the lecture. Welcome to SLD Resolution. This is kind of the crux, as the rock climbers say, of our course. If you master SLD Resolution, you've pretty much got all the hard parts of Prolog. So, SLD Resolution is how Prolog works under the covers. SLD Resolution stands for Selective Linear Resolution with Definite Clauses. If you don't worry about it, if you're panicked, we're not going to define that. Pill, I'm not going to stop and debug the this in the middle unless you can suggest one simple place to look. So Prolog is all right, I'm going to like back up here. The audio issues were kind of distracting me. Okay, so SLD resolution is selective linear resolution with definite clauses, and no, we're not going to go into what that means. But it's important that to realize that while Prolog is a logic language, it's actually a dual paradigm language. It's dual paradigm not in having different pieces that are different paradigms, but in the fact that the logical paradigm is only one way of understanding your code. Because the imperative way is a perfectly valid way to understand Prolog code. And imperative code is and the reason you can get away with saying, well, these are both make sense, is that the algorithm used to search for proofs is simple enough that you can understand it as a human and reason about it. Okay, every language has a paradigm, right? Every language has a model of what execution is. For Haskell, that's evaluating a function. For Python, that's follow a set of instructions. For us, it is logical proof search. So every language also has an a default execution order. For Python, it's read from the top of the file down to the bottom, unless you encounter a control structure or a function definition. For Prolog, we have a single algorithm, the SLD algorithm, that basically does a tree search through the solution space. So Prolog runs like a two-stroke engine. You start with a goal. You run the unify stroke. You find something that is a possible solution and then you substitute in the preconditions, which is the body of the predicate, or the clause for us, and then you do it again, and you keep doing that until you've either consumed all of the things you have left to prove, or you fail and backtrack, or you succeed. Prolog. So why would you build a language like that? Well, it's actually pretty straightforward. I have a thing to prove. I find something that would imply it. So I can prove that Rosie is my mother if Rosie is female and Rosie is my parent, and then I just have to prove that Rosie is female, and we get and so it goes. This is pretty much what humans do. You have to break something down into pieces, and you prove each piece. If one thing doesn't work, you unwind and you try something else. Okay. Questions? Feel free to stick stuff in the comments. I am going to depend on you to ask questions there, because if I stop and wait, which would be my normal thing in a live lecture, then I have to wait for the 10-second pause. Okay. So the unification stroke. This is where most of the interesting part is. You look downwards from the top of the file and find a topmost candidate clause that could possibly be a solution, or that could possibly prove your current goal. I'm going to pull up some code here. This is my redneck family tree, and we're going to look at when I might trying to prove something very simple. Let's try to find out if Dawn is male. So what it's going to do here is it is going to look downwards through the file, and it's going to ignore all the females, because even the functor, this part on the left is the functor, even the functor doesn't match. So we're really only interested in this part of the file. And then we're only going to be able to match the ones that have the left argument. Now, when Prolog loads your code, it does something called indexing. When it finishes loading the code, it's going to take all of the stuff it's loaded, and it's going to create like a database table index. And that table is extremely read optimized. Basically, you have to recreate the table if you make changes. And this table is read optimized not only for the functor, but for the arguments. I had a demo here. I'm going to stick that back in. That was a good demo from the EU session. Here I've got foo, and I'm going to compile. And if I if I ask it if this is true, it's going to say yes, and it's not going to leave a choice point. That means it already knew that the other clauses of foo did not match. It had already figured that out. And that's because that was actually a computation done by the indexer. This despite the fact that these lists are actually lists. So they're actually deeply nested structures of const cells. So foo is going to be, Prolog's very, very good at this indexing, and only on touches the indexer. I would try my hand at almost anything else in Prolog, but certainly not the indexer. Okay. So that's how this select the topmost candidate clause buries a lot of decades of experience developing in this. All right. Now, it might be possible that we have other choices. If that's true, we're going to leave a choice point. And you can see that the quality of the indexer is how few spurious choice points it leaves behind. If you want to test the quality of a Prolog implementation, try my little foo example. Once that happens, we take the goal that we have, and we're going to unify the head of the clause with the goal we want to prove. So this is how argument passing happens. We take each argument, we're going to unify the compound term that is the head of the goal, if it's a compound term, and we're going to take, that means they have the same functor, and then we are going to try to unify each argument. Obviously, if we can't, we don't have a choice. We have to go on to another choice. If we can, however, we're going to make the variables share going in and out, and that'll be how our information will get in and out of the predicate. So we will unify the head of the clause, and at that point we have to deal with failure. What if we can't find one that unifies? If we can't find one that unifies, we reset the computation last choice point. Am I making sense to people? Give me some feedback here so that I know I'm not talking into outer space. If we fail, we're going to reset the computation. We'll go back to that last choice point, and we will take the next choice. If we run out of things to prove, that is, we've run out of things on in our stack frame, then we will pop the stack frame, and now we have proved the first thing, and we can go on to the second one in this list for the next stack frame up. And so we proceed until we get all the way back to the interactor. That's the downstroke. The result, that's the unification stroke. The resolve stroke is even simpler, is really simple. All we do is we make a new stack frame, and then we take the head, we substitute in the body. And when we do that, that's the resolution stroke. Okay. So what happens here? Well, I've kind of been waffling about it, but I'm going to be more explicit. What actually happens is that the body, the comma is an operator, and so what looks like this in the source code is seen by Prolog as this nested series of comma 2 compound terms. So there's always just one thing to solve, but of course comma is just just defined as call the first thing, and then if it succeeds, call the second one. Questions, feedback, comments? It's really notable. I get lots of feedback during the European session and very little during the US one. So let me know how I'm doing here. Okay. So, hammer story. Sally goes into a hardware store and says, I'm putting in fence posts. I need a really big hammer. And the guy behind the counter says, hang on, and he pulls out a framing hammer and says, well, this too, and she says, no, this is like, I need a really big hammer. And so he puts that back, and he gets out a little hand sledge and says, well, this is pretty big. How about this one? And she says, no, I need a proper two-handed sledgehammer. How about you got anything bigger? And he says, well, hang on. I had one in the back. Can we redefine neck and comma? Really great question. Let me finish the hammer story and I'll answer it. So the guy goes in the back and he rummages around. He comes back out and says, I'm sorry, we must have sold it. There's no bigger hammer there. So Sally leaves. Okay, the point of this little story is that Sally has been offered the bigger hammer. That is, the hardware guy had a belief that he had more choices. But in fact, none of those worked out. That's why you will get a failure in your last choice point. That's why, for example, oftentimes you will step through a bunch of choices and then I'll say false at the end. Okay? And now I'm going to answer Matthew's question. Can we redefine the neck operator and comma? Basically, no, because the compiler optimizations will totally freak out if you do it. A few things are basic Prolog structure. The colon operator is pretty deeply embedded in the language because it runs the module system. The neck operator is basically not is basically interpreted by the lower end stuff. When we're grinding through source code, we're either going to see a unary neck operator, or we're going to see a binary neck operator, or we're going to see a fact. And it is hard coded what it does with those three things. The comma operator is in fact is also pretty much that same way. It's built into the language. That doesn't mean you can't go ahead and define new operators that do something else. There is a kind of a joke pack called Pack Evil And one of the things it does is offer the other binary operations besides AND, so that you can do that. But no, if you changed either of those, you would no longer be working with horn clauses. And Prolog was pretty much all designed to work with horn clauses. So no, those are the two things that are pretty much foisted upon you. Okay, Joe is typing something. I'm going to wait for him. Could you make the comma operator evaluates arguments in a different order? Well, there's only one other order. But you mean make it read right to left? No. No, because you can't redefine the comma operator. So you're pretty much stuck with that. That depth first search is inherent to Prolog. Now, what you can do, and actually people do all the time, is define a new operator. You could define your own operator, and in fact we're going to be getting into DCGs, definite clause grammars, where you write things like, I'm going to type this into the Slack because it's clearer than doing something via video. That's valid Prolog. That arrow will be, by term expansion, turned into a rule. And by using this, we can make parsing a fundamental operation in the language. So this is a sentence. So yes, you can make up your own thing that does something different. And in that sense, yes, Matthew, you can make up your own thing that does something else. CP-Lint, the probabilistic logic programming language, you say I've forgotten the exact syntax, honestly, but so forgive me for this not being exactly right, but this is some CP-Lint code that would say, well, if you have BAS, 80% of the time that implies foo, but 20% of the time that implies BAS. Excuse me. In CHR, you can write things like yellow and blue paint becomes green paint. So you can make your own stuff, but the neck operator is kind of the base that everything else is built on. Okay. I am going to take a break and wait for the delay, and when people are ready, I don't think I'm going to get any comments, so okay. So I'll go on to commitment. All right. Getting married is a commitment. You can go out for coffee, and date a bit, have a bit of a thing going for a couple months, but you get married, you're committed. So when you commit, you cut off your other choices. You say, I'm doing this and not the other one. And for us, commitment is signified by the cut operator, which is the exclamation point. So it's just a operator with 0 arguments. You just say bang. Now what happens when you have a cut? A cut operates on the current predicate. So it will discard all the other clauses. It'll say, this is the clause I'm going to use, not any others. It will discard any choice points you made since you entered the predicate. So if you are on your 5th goal in the predicate, and somewhere about it you made a choice point, that choice point's gone. Okay, why would we want this? Well, I've been using the car keys example. I've lost my car keys. I look on my nightstand, not there. I look in the kitchen, not there. I was doing some stuff in the garage right after I got out of the car. Maybe I set it down. I go out to the garage. It's not there, so I look in the car, and yeah, I left them in the ignition. So I retrieve my keys, and now the one thing I don't do, am I going to, there is no point in looking in my pants for my keys. Why? And now I'm going to stop and, why shouldn't I look in my pants in the wash for the keys? I might have taken my pants off, put the keys in my pocket, taken my pants off, and dropped them in the wash, and so that's not a bad idea, it seems. But why shouldn't I look for my pants? Shouldn't I look in my pants? Please answer in chat. What's wrong with looking in my pants? Is anybody with me? Am I still there? It says I'm streaming. Can you hear me? Is life good? Yeah, because we already found them. Okay, because we already found them. And we know that I have one set of car keys. So having found them in my car means that they cannot be in my pants. But we don't want our to write our prologue in a way that says they're in your pants if, you know, they were put in your pants and they aren't in your car, right? We don't want to have to put all of those and everything else, and we didn't find them already conditions, because they're very common and very cumbersome to program if you don't have the cut. What is the difference in the... Yeah, Joe's explanation is good. Ooh, there's 40 to 50 seconds of lag. Okay, I will be aware of that. All right. Yes, there. Okay. Okay, so it can be a little unclear. It can be a little unclear if you are within a call or if you've got a call or you've got an if or something in your predicate. It can be a little unclear exactly how much gets cut. There is an effective rule for what blocks cuts. There's a rule of thumb by Richard O'Keefe. Words block cuts. If you are within a context of something that is defined with a functor that is a word rather than a symbol, that blocks the cut. That's a very cool little rule. Okay. Look, guys, I am at the conclusion of my presentation. The lag is quite bad. I think I'm going to just continue via Slack.